The single responsibility principle is the first of the 5 solid principles compiled by Robert C. Martin in the year 2000. These aren't rules or specific design patterns, they are high-level guidelines intended to lead to clearer, more maintainable code. The single responsibility principle might sound intuitive. Each class or function should just be responsible for doing one thing. And that's often not a bad idea, but it's not really anything to do with the single responsibility principle. And this is a super common misunderstanding. And some of the confusion comes from the word responsibility, which actually has 2 meanings. It's more common to talk about what someone or some code is responsible for doing. But you can also describe, for example, your manager as someone you are responsible to. It's that second meaning that the single responsibility principle is using. The single responsibility principle states that each part of your code should have one and only one reason to change. But all code ultimately exists to serve some function for us humans. So when our requirements change, we are the reason to change that the principle is talking about. A more intuitive reframing of the principle is each part of your code should be responsible to one and only one role, where each role is a different type of user of your software. As an example, suppose you have an HR app that helps manage employees. This could have a few different types of user. Team members who use the app to track which days they've worked and book holidays. HR managers who approve holiday and view reports to make sure that nobody's working too much. Finance managers who use employee hours worked to determine their pay. Each of these roles will have very different needs, and they are likely to require different changes. Team members might want to record half days off. HR managers might want a new type of report. Finance people might want to change overtime pay calculations. The single responsibility principle recommends that each part of our code base should only ever need to change for one of these roles. But why is this a good thing? The code for this HR app might have a large class team member which includes functionality needed by multiple roles. Here we've got a report data method, which is responsible to the report viewers or HR managers, and a calculate pay method that is responsible to the finance department. Now, suppose we get a feature request from the finance team who want weekend days to be paid at double the normal rate. An unsuspecting developer might look at the code and be delighted to find that the method they want already exists, equivalent days worked. It's a clearly named method which just does one thing. They should be able to just count weekend days as double and add some tests that the pay calculation has been updated as expected. What could possibly go wrong? Except, the next time an HR report is generated, each weekend day is counted twice. An employee working Wednesday to Sunday would be reported as working 7 days every week, which would probably raise some alarm bells. The problem here is that multiple roles rely on the behavior of equivalent days worked, but would naturally assume a slightly different meaning for the function. To the finance team, it should return the equivalent number of days from a pay perspective. To the HR team, it should return the equivalent number of days from an hours worked perspective. Both are reasonable interpretations of the method name, so it's hard to avoid this sort of confusion. Because both the finance department and HR care about the number this method produces, it's easy for a change for one of these roles to have an unintended side effect for the other. This gets to the purpose of the single responsibility principle. If code only ever needs to change for one role, then it is much easier to safely change. Our team member class looks a bit like what's sometimes called a God object. It is all-knowing and works in mysterious ways. A useful approach to simplifying some of these problems is to separate the data from the main functions that use it and split those functionalities by their responsibilities. For example, the code from earlier could be separated into 3 separate modules. 1. A data class that just holds the information about a team member. 2. A class that builds HR reports about a team member. 3. A module that deals with pay calculations. Notice that this adds a bit of duplication. something we should usually be very keen to avoid as software engineers. Both finance and reporting have a method called equivalent days worked. But this separation is actually desirable. These functions happen to be the same for now, but they are serving different purposes. One is equivalent days for reporting, and the other is equivalent days for payment. These two things might change for different reasons, so belong in different modules. Now, if a change is requested by the finance team, you should only change code in finance.py. There are lots of other ways you can organize your code to separate out responsibilities, but it's always important to ask who is likely to require changes to this module. If the answer includes more than one role, then you should consider changing the structure. If your code follows the single responsibility principle, you're also likely to see other benefits, such as limited damage from bugs, since code errors will only affect one role, fewer merge conflicts, since different teams or work items are less likely to require changes to the same files, easier to read, write, and maintain code tests, and more stable code that changes less often, making it easier to look back and see, for example, all changes made to financial calculations this year and why. So to recap, if your code has multiple potential reasons to change, then a change for one role might have an unexpected negative effect for other roles. The single responsibility principle should push you towards splitting up your code by the roles it is responsible to. This way, it's easier and safer to make changes.